Imagine the cosmic darkness, punctuated only by the milky glow of distant Earth and a suspended, eternal moon awaiting humanity's return. Soon, an artificial object will begin to orbit our satellite steadily, marking a technological and cultural leap destined to redefine our presence in space, the Gateway Station. While the International Space Station has now become almost routine, a stable platform in low Earth orbit, Gateway promises something radically new. To become the first permanent human outpost in lunar orbit, the frontier separating Earth's familiarity from the deep abyss of space. The very idea of a station orbiting the moon, pure science fiction just a few years ago, is now a hive of activity. The project stems from a collaboration between NASA, ESA, JAXA, and the Canadian agency, aiming to create a modular and resilient structure, capable of hosting crews and advanced robotics for extended periods, and serving as a launch base for expeditions to the lunar surface, and, in perspective, to Mars. The core of the station will be the so-called NRHO, Near Rectilinear Halo Orbit, a highly elliptical orbit inclined with respect to the lunar equator, which will guarantee an almost magical compromise, minimum distance from the lunar surface to facilitate missions, while at the same time ensuring constant visibility of Earth, essential for communications and crew safety. In the silence of deep space, Gateway will be much more than a laboratory. It will be the meeting point between autonomous robotics and human presence, between the search for new resources and survival in hostile environments. The first section, called Halo, Habitation and Logistics Outpost, will provide both accommodation and logistics functions and will be docked to the PPE, Power and Propulsion element, a technological platform equipped with ion propulsion systems and high-efficiency solar panels. This combination will guarantee continuous energy and the ability to modify the orbit, a fundamental strategic advantage in case of unforeseen events or new operational needs. It's not just a matter of engineering. Gateway is the ideal laboratory for testing life far from Earth, with all its biological, psychological, and technical unknowns. Prolonged exposure to cosmic radiation, sleep cycles disturbed by the moon's rotation, the necessary isolation from any immediate support. Here, more than ever, human resilience will be put to the test. Scientists will study the impact of radiation on materials and living tissues, the psychological adaptation of crews, the growth of food crops in closed environments, the use of 3D printing for repairs. Each of these experiments will not be an end in itself, but a piece of the mosaic for the future colonization of extraterrestrial environments. The construction schedule for Gateway is marked by increasingly close milestones. The launch of the first modules is expected by 2027, with a first human presence shortly thereafter. Unlike the ISS, built through a succession of launches and assembly in Earth orbit, here the challenges are on a whole different level. Each launch will have to precisely target an orbit tens of thousands of kilometers from Earth, facing enormous risks and costs. Yet, international determination has transformed competition into extraordinary synergy, with private companies like SpaceX and Northrop Grumman involved in building the transport and supply vehicles. In this dance between innovation and tradition, Gateway also aims to be the collection and relaunch point for advanced robotic exploration. Automated spacecraft, rovers, and landers will be able to dock at the station, receive maintenance, or prepare for new missions on the lunar surface or even towards nearby asteroids. The role of robotics will also be fundamental in the absence of a human crew, keeping the station operational and constantly monitoring the state of vital systems. While the first renderings fascinate the public, behind the scenes, cutting-edge solutions are being developed that may seem almost invisible but will determine the mission's success. Life support systems, for example, will have to guarantee not only filtered air and water but also almost total resource recycling, with efficiency far surpassing that of current Earth-based stations. Electric propulsion technologies, still experimental on a large scale, will undergo continuous stress tests to assess their resistance and maneuverability in environments with minimal gravity and extreme temperature variations. Geopolitical aspects are closely intertwined with science. If the ISS was the symbol of post-Cold War collaboration, Gateway reflects a new era, in which the United States, Europe, Canada, and Japan moved together, while other space giants like China and Russia are developing their own autonomous lunar station projects. It is a moon race 2.0, but with more sophisticated goals. No longer just planting a flag, but inaugurating a sustainable presence, capable of producing innovation and knowledge at an accelerated pace. The excitement surrounding Gateway is not limited to professionals. The involvement of innovative startups, universities, and young researchers opens up completely new perspectives. Self-healing materials are being tested, sensor networks capable of predicting failures before they occur, optical communication systems to transmit enormous amounts of data to Earth in seconds. Artificial intelligence, the silent protagonist, will be present in every module to monitor vital parameters, support navigation, suggest problem-solving strategies, or, in extreme cases, take control of the station to ensure crew safety. Perhaps the most evocative aspect of Gateway is its function as a bridge, not only between Earth and Moon, but between what we have been and what we might become. It will be from this outpost that the next generations of explorers will take their first steps toward unknown worlds. The station will serve as a testing ground for building permanent lunar habitats, from which oxygen and water can be extracted using local resources, realizing a vision that until yesterday was confined to science fiction novels. Survival in the lunar environment will require new energy solutions, which is why there is already talk of small nuclear reactors, adaptive solar panels, and highly advanced storage systems, technologies that could then be transferred to Earth to improve global energy efficiency. But Gateway will also be an ethical laboratory. In such an extreme environment, every decision must be evaluated not only in terms of efficiency but of long-term sustainability. What will be the limits of decision-making autonomy entrusted to artificial intelligence? How will medical emergencies be managed when days away from Earth? What impact will electromagnetic emissions and waste production have in space? Every answer will write a new chapter in the history of human exploration, testing not only technology but also our very capacity to cooperate, innovate, and adapt. And as Gateway prepares to become reality, questions multiply about its unexplored potential. What scientific mysteries will this platform reveal, observing the Moon and Earth with unprecedented instruments? Through biological and physical experiments, will we be able to lay the foundations for the birth of a true space civilization, capable of thriving far from its home planet? And how will our species' self-perception change once we live stably off Earth, gazing at the blue world from a window suspended over nothingness? In short, Gateway is not just a space engineering project. It is a catalyst for radical questions, an engine of transformation that calls us to reinvent the very concept of home and community. And if today we still see it in renderings and digital models, tomorrow it could be the starting point for journeys that will surpass every dream or prediction. If the Gateway Station represents the threshold of a new era, its daily operation hides the true miracle of human engineering. A living machine, designed to function without margins for error, where every resource is precious and every detail must be anticipated, simulated, and tested to exhaustion. Communications between Gateway and Earth, for example, must be constant, robust, able to withstand solar storms and technical mishaps. New optical transmission technologies, such as deep space communication lasers, promise to send images and scientific data in unprecedented quantities, ensuring a continuous link that will drastically reduce delays and increase the involvement of scientists and technicians back on Earth. One of Gateway's most revolutionary aspects will be its modularity, conceived from the outset to adapt and expand, welcoming new laboratories, advanced habitats, and even modules developed by private partners. In this sense, the station will serve as a testing ground for the future of space infrastructures, a model of incremental construction, akin to a living organism that evolves and adapts according to needs, budgets, and new discoveries. This approach opens the door to a true lunar orbital economy, in which startups and universities will be able to experiment with new materials, test autonomous robotic technologies, grow resilient plants and microorganisms, while also exploring solutions for the long-term health and well-being of astronauts. Human missions launched from Gateway will finally be able to systematically reach the lunar poles, exploring areas that until now have been almost inaccessible, such as the permanently shadowed craters where water ice is hidden, a crucial resource for the future of exploration. Here, scientists and engineers will try to extract water and oxygen directly from lunar soil, inaugurating a new era of ISRU, in situ resource utilization. The principle that every space colony must draw on and transform local resources to be sustainable. If successful, these experiments will transform the Moon from a mere object of study into a truly habitable and self-sufficient frontier. On the safety front, Gateway will have to face threats never before systematically tackled: micrometeorites, solar radiation storms, systemic malfunctions that, at these distances, cannot be solved quickly from Earth. For this reason, every module will be equipped with advanced protective shields and multiple backup systems, while next-generation artificial intelligences will constantly monitor every vital parameter, ready to intervene autonomously at the slightest sign of trouble. The psychological health of crews will also be a priority. Periods of isolation, cycles of artificial light, and separation from loved ones can only be mitigated by designs centered on human well-being, integrating recreational spaces, immersive digital supports, and even, prospectively, virtual reality as an emotional bridge to Earth. The scientific impact of a lunar station will be incalculable. Gateway will offer an unprecedented platform for fundamental physics. In the near-total absence of terrestrial gravity, new materials can be studied, sensors for detecting gravitational waves tested, even the behavior of subatomic particles in extreme conditions observed. At the same time, astronomers and astrophysicists will be able to exploit the station's privileged position to conduct deep observations, free from atmospheric and terrestrial radio interference. The instruments on board will be able to peer into deep space with never-before-achieved clarity, perhaps detecting the faintest signals of as yet unknown phenomena or even extraterrestrial life. But Gateway will also be a school of adaptation and social experimentation. How will new habits, rhythms, and dynamics form within a space community? What rules of coexistence will be necessary in such a confined, stress-laden environment? Psychologists, sociologists, and anthropologists will have a unique opportunity to study the evolution of human relationships without terrestrial roots, perhaps laying the foundation for future societies that may one day live on Mars or distant asteroids. No less fascinating is Gateway's economic potential. Even now, major companies and startups are developing orbital transport, logistics, and maintenance services, betting on a future where human and robotic presence in space will be routine and a source of wealth. The concept of a lunar portal could become a reality, a commercial hub for the transfer of resources extracted from the Moon, fuel produced in situ, even space data centers capable of offering ultrafast and secure storage services thanks to the unique conditions of deep space. Yet, beyond the practical and technological aspects, there is a philosophical dimension that no machine will ever exhaust. What does it truly mean to establish a permanent base outside our planet? What profound change will occur in our way of thinking about Earth, life, the future of the human species? Gateway, with its silent and constant presence in the lunar sky, will force us to rethink our place in the universe. No longer mere inhabitants of an isolated world, but protagonists of a story that expands beyond known boundaries, seeking answers to the oldest and most mysterious questions. And perhaps, from this small station suspended between Earth and Moon, will come the definitive push for the next great leap. The transformation of humanity from a planetary species to a multiplanetary civilization, capable of inhabiting, thriving, and loving even in the most inhospitable places in the cosmos. On this journey that is just beginning, Gateway will be our compass, our laboratory, our beacon toward the future. If you've made it this far, it means you love curiosity as much as we do. If you enjoyed this journey, leave a like, Write a comment, and subscribe to the channel. It's the best way to support what we do. Your presence truly makes a difference. Until the next exploration.